Hello and welcome to the Microgrids and Smart Grids Design Integration and Future Trends class. This is the special topics class known as the EENG 4392 or the special topics for graduates 6392. My name is Dr. Behnam Askarian. I'm the instructor for this course. My email address is baskarian@wtamu.edu and my office is Engineering and Computer Science 221J, also known as ECS 221J. My office hours are Monday, Wednesdays, 11 a.m. to 1 p.m., or by email appointment. If you have any questions, I'm usually in my office on Tuesdays and Thursdays after 12:30 p.m. as well. And if you have any questions, just please email me. I will try to reply to your email as soon as possible. But if it's during the weekend, just please give it 24 to 48 hours for me to be able to respond. Now, the text and other materials for this class are recommended and not required materials. I will provide you with all the texts and PowerPoints necessary for this, so you don't need to purchase any. But if you want to buy them for your own, if you are interested to dive deep into some of the topics and you want to solve some of the homeworks and examples, these are the books that are recommended for this class. The Microgrids and Active Distribution Networks by Chaudhary and Crossley, and the Smart Grids, Fundamentals of Design and Analysis by James Momo, and also the Renewable and Efficient Electric Power Systems by Gilbert Masters. Now, for the course description, this course provides an in-depth examination of microgrids and smart grids as integral components of modern power systems, and we would emphasize mainly on renewable energies such as solar, wind, hydro, geothermal, and we would explore the design and operations of microgrids and smart grids and examine their ability to function independently. And we would also heavily focus on storage systems, because as you know, one of the drawbacks of renewable energies and the grid currently is the problem with the storage. So storage systems such as batteries, supercapacitors, hydrogen storage systems, fuel cells, and also the hydro storage systems as well, and other types of storage systems such as flywheels. Now, in this course, we also delve into the emerging role of smart grids in incorporating distributed energy resources, or DERs, their advanced control technologies, a little bit about cybersecurity, the impact and the role of machine learning applications, real-time management, and also economic and environmental impacts of grid modernization, cybersecurity, as mentioned, policy frameworks, future trends, AI, machine learning, and blockchain and energy systems. Now, the student learning outcomes as required by ABET is basically ability to identify, formulate, and solve complex engineering problems by applying principles of engineering, science, and mathematics, critical thinking, ability to apply engineering design to produce solutions that meet specific needs, ability to communicate effectively with a range of audiences, teamwork, critical thinking, problem solving, ability to recognize ethical and professional responsibilities, ability to function effectively on a team whose members together provide leadership. Again, teamwork is very important, and I'll give you some projects for that. Ability to develop and conduct appropriate experimentation, and ability to acquire and apply new knowledge as needed. And you're already familiar with most of these as well. Now, for this specific course, the course objectives would be to understand the fundamentals of microgrids and smart grids, and their role in modern power systems, analyze renewable energy sources, and assess their potential for integration into microgrids, explore various energy storage technologies and their applications in balancing grid load and supply, to design controls strategies for efficient grid operation with renewable energy and storage integration, assess the economic and environmental impact of smart grid and microgrid technologies as well. And please read through the program learning outcomes for West Texas A&M as well. Now, another important part is the course requirements and evaluation. And for this course, 20% would be the quiz, class activity, and homework assignments. I would also give you 2 projects, which is going to be part of this. The class activities would be those projects. So class activities will be the projects. After each video is posted, you would have a quiz to take. So each week you're going to have 1 quiz. You would have a 1 week to take the quiz. There would be no extension for the quizzes. And immediately after the video is uploaded, the quiz would start, and you have, again, 1 week to complete the quiz. It's the same thing for the homework. I would give no extension. There's no excuse for any late submission. A late submission would be an automatic 0, and not taking the quiz on time, if it's past 2, it's going to automatically deactivate, and it's going to be an automatic 0 on that as well. We're going to have 2 midterm exams. Each midterm exam would be 25% each, and I would announce the date for the midterms exams in the first week of February, probably. And the final exam would be 30%, and the total would be 100%. Now, the standards 90 plus would be an A, 80 to 90 is a B, 70 to 80 is a C, 60 to 70 is a D, and below 60 is an F. And in most situations, below C is a automatic repeat. You have to repeat the class. So failure to take the final exam results in an automatic F for the course. Failure to take an exam or quiz at time schedule results in an automatic 0. Now, the tentative calendar for this course, for the first week, we're going to have introduction to microgrids and smart grids, overview of traditional and modern power grids, microgrid architecture and components, AC and DC microgrids, smart grid technologies. For week 3, communication networks and data management and smart grids. Week 4 is going to be renewable energy sources such as solar, wind, hydro, geothermal, and grid integration challenges. Week 5 is going to be energy storage technologies, batteries, flywheels, supercapacitors, and hydrogen storage. Week 6 is going to be control and optimization of microgrids, demand response and load management. Week 7 is going to be distributed generation and distributed energy resources, inverters, and power electronics. Week 8 is going to be economic analysis of microgrid and smart grid investment, cost benefit analysis, and financial models. Week 9 is going to be advanced control strategies in microgrid and smart grids. Week 10 is going to be policy standards and regulations. Week 11 is going to be security and reliability in smart grids. Week 12 is going to be real-time monitoring and grid analysis. And week 13 is going to be hybrid renewable energy systems, design and simulation tools. If we have enough time, we're going to go through future trends, and finally it's going to be the project presentation as well. And in the last week, we're going to have the final exam and the course review. Now, please read through all the policies and responsibilities for the course. One thing that I want to mention is the use of generative AI, and I have to recalibrate that. But generative AI is strictly prohibited in this course. So any use of generative AI in the quiz and any of the exams or the homeworks is strictly prohibited. If I see any use of ChatGPT or any other generative AI tools in this course, it's going to be an automatic 0 for this course. So please keep in mind that any use of generative AI for this course results in an automatic 0. Okay. For any of the quiz, uh, homework, exams, I had a lot of problems in the last semester on students using generative AI. So please don't use any type of AI or other online tools to solve the problems, do the assignments or the quiz or exams. And that's it for copyright and also the other safety statements as well. Just please read through it. Now, for the course itself, I have uploaded the lecture notes and I'm going to revise them. If some of the lecture courses needs updates, I would update them continuously. Another part that I have added is the class podcast, and I would highly recommend that you listen to this podcast, especially it's very helpful for online students when you're driving and you want to listen to the course materials. The course class podcast is going to be a great tool. I'm going to just open one of them and you can play it or you can download it and play it on an MP3 player or on your car. So that's one. And I would add another link to the lessons, which is going to take you to the YouTube channel. If you click on that link, it will take you to the YouTube channel, and that YouTube channel would uh, contain all the videos for the class. Under the lessons, you're going to see the quiz and also all the projects and exams and everything else. I've started uploading them one by one, and also the class podcast, the class lecture. I would add a few more. And if you have any questions about the course content and the videos, just please email me. That's it for the first class and the introduction. I would see you in the next class. Thank you so much.